Okay, guys, we're going to be working on something that's a little bit difficult. It starts easy and then it progressively gets a little bit more challenging. So you're going to want to make sure you're paying attention early and following along and making sure you're trying the examples when I tell you to try those examples. That's going to be really important. We've been working with exponents. Now we're looking at square roots. A lot of the same rules apply for these. But we're going to start by simplifying things that are just numbers. And when we're simplifying things that aren't perfect squares, remember a perfect square is a number times itself, like 7 times 7. So the perfect square would be 49. We're looking at things that aren't perfect squares, though. And we're going to do this simplifying them by breaking numbers into factors. One of them, though, needs to be a perfect square. So I'm going to show you what I mean here in a second. When we're looking for things that are perfect squares, we need to think, okay, what number could I multiply by to get to there? And one of them is a perfect square. So for example, 12. We could do 1 times 12. Are either of those perfect squares? Well, 1 is, but that's not going to help me simplify that. So then I'm going to go 2 times 6. Neither of those are perfect squares. 3 times 4. Okay, 4 is a perfect square. So we're going to break the square root of 12 into the square root of 3 times 4. And I'm going to do this because this means the same thing as the square root of 3 times the square root of 4. And what I can do is take the square root of 4. The square root of 4 is 2. So this is 2 times the square root of 3. I've simplified this square root of 12 into 2 times the square root of 3. You'll know something is simplified all the way when there are no more perfect squares inside of the square root. Okay, so looking at the next one here, the square root of 90. Okay, so let's think here. Factors, 9 and 10, right? 9 and 10 work. So I could do the square root of 9 times the square root of 10. And I could break this down even further. This is the square root of 9 times the square root of 10. Okay, the square root of 9 is 3. All right, then I have the square root of 10, and now I need to ask myself, are there any other perfect squares in this factor of 10? And the only other factors of 10 are 1 and 10, which does me no good. 2 and 5, neither of them are perfect squares, so I'm done. Okay, let's look at one more, 33. Square root of 33. So I've got, let's see, 1 and 33, no, 3 and 11. Doesn't look like there's any perfect squares inside of the square root of 33. So I will just say this is simplified. This is already in simplest form. Okay. Looking at this next row here, we can multiply these together. So this is just the same thing as the square root of 45. That's the same thing. And now I need to ask myself the same question. Are there any perfect squares inside of root 45? And it turns out there are. This is the same thing as the square root of 9 times the square root of 5. Right? 9 times 5 is 45. I wanted to do this because 9 is a perfect square. The square root of 9 is 3. So this is 3 times root 5. Okay, I'm going to have you pause this and try just the next one, just number 5. Okay, so hopefully you paused it. First of all, we should have multiplied these knowing this is the square root of 28. But you might have caught this before you did this. This is already a perfect square, so there is no need to multiply here. This is 2 times root 7. Now, if you did this, that's fine. Your factors would have been 7 and 4, so you would have been right back to the same thing, right? The square root of 7 times the square root of 4, and you did the same thing, but hopefully you recognize right off the bat that 4 is a perfect square. Okay, one more. I'm going to have you pause one more time and just try number 6 now. Okay, and number 6, neither of these are perfect squares, so we'll go ahead and multiply them. This is 11 times 5, which is 55. Now, I'm thinking about factors of 55, and I'm not seeing any perfect squares in there, so this one is also in simplest form. And that one's done. Okay, Moving to these last two down here, 7 and 8, we can kind of think of this as two different kinds of combinations. So I can multiply my outside terms, 2 times 5, that's 10. And then I can multiply my inside terms as well. 27 times 3 is 81. Okay, here the square root of 81 is 9, so this is just 10 times 9, which is 90. Cool. I'm going to have you pause it and try number 8. Okay, looking at this one, we would do 4 times 3, which is 12. And then the square root of 2 times the square root of 2 is the square root of 4. Well, we know the square root of 4 is 2, so just 12 times 2, so 24. Oh, I should have just circled 24. Okay, cool. So hopefully this all makes sense. The next page here, it tells you you're going to go through these radicals and simplify them. So you'll look at like the first one and you'll say the square root of 0, well that's 0. And then you'll read the directions. If it's a perfect square, you color that box red and you can just lightly like kind of scribble in there. And then we look at the next one, the square root of 1 is 1. Oh look, that's also a perfect square. Okay, I'm going to do one that's not a perfect square. Let's do number 4. So I'm looking for, my factors of 8. 8's not a perfect square. So I can break this down though. I know that 4 is a perfect square. And the square root of 4 times the square root of 2 is 8. So the square root of 4 is 2. And I can't do anything with this root 2. So it's 2 times the square root of 2. Now, if you look up top, it says if the radical has a factor of 2, meaning there's a 2 on the outside, you'll color that square orange. So in this box, I don't have an orange marker, but I'll shade that one orange. If this outside factor was a 3, you do that one yellow. If this outside factor was 4, you'd do it green. If the outside factor was 5, you'd color that square blue. If the outside factor was 6, you'd color it purple. And if your outside factor was none of those things, you'll just leave it white. So I'm going to give you some time. You're going to pause this video. When you start it again, all the answers are going to appear. And I'm just kind of trusting you right now that you're going to do the right thing and try them because you do need this practice before we go on to the next step. So take some time here, try all of these, shade in the box, and then we'll come back together. So pause the video now. Okay, so now I'm going to have you pause the video again and just check your answers. Hopefully I didn't mess anything up. These two are probably ones that were a little bit tricky. So check out what I did if you did not get those right. So pause the video now. Okay, welcome back. We're going to go on to the next page. So now we're looking at things with variable exponents. First of all, when you take the square root of an exponent, you're dividing that exponent by 2. Now, let's say that you've got something like x cubed, right? Obviously, I can't divide this by 2, right? Like if I had x2, that just equals x. The square root of x squared is x. But the square root of x3, I can't divide that by 2. So what we're going to do is we're going to break this into factors that I can't, just like numbers. Okay, x2 times x1 is x3, right? Our exponent laws, when I multiply exponents, I'm actually adding them. So now I can say, well, the square root of x squared is x, and I can't divide that by 2, so x cubed, the square root of x cubed is equal to x times the square root of x. Similarly, if I had, I don't know, let's do another one. Let's do like x9, okay? I can't divide x9 by 2, but I can divide x8 by 2. And if I did the square root of x to the 8th times the square root of x to the 1st, I'm going to be back to, the square root of x to the 9th, right? 8 plus 1 is 9. All right, so if I divide this by 2, I'm going to get x4. And I can't divide this by 2, so it's just x. Okay? As we do more of these, I think it will start to make sense to you. So anytime we have an exponent inside the square root, you're going to divide it by 2. Coefficient numbers, however, like your 40, 27, 60, 36, they operate the same way as before. So we need to break those into perfect squares, and and then another factor, right? Just like we just did. Okay, those are two terrible underlines, goodness. So let's look at two together, and then I'm going to have you try two. Starting with this one. So I'm going to always start with that coefficient. I want to break 40 into two factors, one of which being a perfect square. And I know that 4 times 10 will work, right? 4 is a perfect square. Okay, looking at my exponents, I need them to all to be even so that I can divide them by 2. So x4, that's going to divide by 2, so I'll leave that alone. y5 will not divide by 2 because it's odd. So I'm going to do just like I did up here. I'm going to break it into two factors. I'm going to break it into y4 times y1, right? I'm trying to simplify as much as I can. And I can divide this by 2, but I cannot divide this by 2. Same with z3, right? Z3 is odd, so I can do z squared times z to the first. And now I'm ready to simplify these. So I can take the square root of 4. That's 2. I'm going to cross through it. It's done. I cannot take the square root of 10, and there are no more perfect squares inside of 10, so I'm going to leave that inside. x4, the square root of x4, just divide it by 2. It's x squared. y4, the square root of y4 is y squared. I cannot take the square root of y1. That will stay. The square root of z squared divided by 2 is just z to the first, and I can't do anything with that. So all the things that I couldn't take the square root of will stay on the inside. So 10 is going to stay on the inside, y1 is going to stay on the inside, and z1 is going to stay on the inside. And that is my answer. Holy cow. Whoa. Those things are crazy. Let's do one more together. Let's do 27. So I need to break 27 into two factors. One of them is a perfect square. And I know that 3 times 9 is going to work out for me, right? 9 is a perfect square. x5, I cannot divide x5 by 2, but I can break it into two factors because I can take x4, can divide that by 2. y4 is good, right? That one's okay. Z squared is good. So now I'm ready to start simplifying what I can. I cannot take the square root of 3. I'll leave that. I can take the square root of 9. That is 3. The square root of x to the 4th power is x squared. It's just divided by 2. I can't do anything with that, so that's going to stay. y4, the square root of y4 is y2. The square root of z squared is z. Everything that's left is going to stay inside, so 3 and x. That's my answer. All right, I'm going to have you pause and try the next one here, the 60. Okay, so for this one, I've broken it into these factors. I'm ready to start taking square roots. So the square root of 4 is 2. The square root of x to the 4th power is x squared. And the square root of y to the 6th power is y3. And then what's left on the inside is 15 and x. All right, you're ready for one more. I'm going to have you pause it and try this last one. Okay, so 36 is already a perfect square, right? It's 6. The square root of x to the 6th power is x cubed. I just have one factor x left. y4 square root is y squared. And I couldn't do anything with poor z, so that's going to stay as well. So inside I have an x and a z. So if none of that made sense to you, I'm going to have you go back and kind of watch some of the explanation of this side. If you're ready, we're going to move on. I'm going to have you try the top row and then pause. We'll check it, and then I'll let you finish it. Okay, so try just these first 4, and you can show your work in these boxes right here. Okay, pause the video now. Okay, I'm going to focus our attention to 15 and 16 first because those are the ones like we just did. We broke it into factors of 4 and 5. I took the square root of 4, and everything else was good. Over here, 100 is already a perfect square. It's 10, and then I just broke my factor of x into x squared times y. Over here, we multiply the outside terms. 4 times 3 is 12. And now I need to break 60 into 15 times 4, which I can take the square root of 4. It's 2. And we're going to multiply 2 times that 12. So it becomes 24. And the inside left is 15. Similarly here, I can take the square root of this. It's 3. So it's going to multiply my outside term by 3. So this is 9, and then the square root of x6 is x3. I'm going to have you pause now, finish the rest, and then I'll have the answer key for you when you're done. So pause it and check the rest of these.